Hello class. Today we're going to be working on your primer worksheet, lesson 1. This is part of the chemistry unit 2 foundation worksheet on your framework. Um, First of all, don't forget to write your name, your period number, and your due date up in the right hand corner. We're going to be going over the atomic theory and atomic structure. First, we're going to be talking about your atomic theory, and it can be found on textbook pages 312 through 317. The atomic theory has been around for thousands of years. This has been going on since the Greeks. And then scientists have developed models since then to explain their hypotheses. And or results of their experiments. Scrunch it in there. An example from this chapter would be the plum pudding model. Of the atom. This plum pudding model was made by J.J. Thomson, and it explained experiments about the atomic structure. Then in the textbook, it goes through a series of scientists. The first scientist that can be attributed to the atomic theory is Democritus. And he was around at the time 440 BC, so very old. And he was an ancient Greek philosopher slash scientist, which, like most scientists back then, they were very smart people. The contribution that he made was naming the atom. And that atom is a very key word. And make sure you know the definition. And that's the smallest particle you can have. It is indivisible. That's what he said. He said it was indivisible. Another scientist back during the time of Democritus was Aristotle. And he was around Democritus, like I said, so around BC. And his contribution to the atomic theory was actually wrong. It set the atomic theory back. He said that particles were made up of earth, wind, and fire, which now we know is untrue. The next scientist that we can contribute to the atomic theory, making of the atomic theory, was John Dalton. And he made his contributions around the late 1700s. So you could say, 1770. And his contribution was he published the first atomic theory theory-based experiments. And this can be found on page 313. Ernest Rutherford was probably the next scientist that, J.J. Thomson, which what we talked about before, was the next scientist talked about in the chapter. And he was around the year 1897. And like we said, he discovered the first subatomic particle, the electron, and came up with the plum pudding model. subatomic particle, the electron. And like we said before, he dealt with the plum pudding model up here. And he called the electron, and he named it at first the negative corpus. Actually, it was called the negative corpus, and now it's the electron. The model known as a plum pudding model. It was a large solid object atom, and in the middle there were small negative charges known as plums. This could be considered like a chocolate chip ice cream scoop. The electrons would be the chocolate chips, and the ice cream that surrounds it would be considered the atom. And that's what made up his plum pudding model. The next scientist would be Ernest Rutherford. And he was around 1911 when he made his contributions to the atomic theory. And he discovered the nucleus and he is famous for the gold foil experiment. And this experiment is really cool because what he did was he shot beams of energy at a gold foil. Some of these beams were then reflected, showing an object was reflecting, and it is now known as the nucleus. So he gave scientific proof that there was a nucleus. And then the next scientist was Niels Bohr. And he made his contributions just after in 1913. What he did was he identified electrons travel on a specific path. And these paths were known as energy levels. He came up with what we still know today as the Bohr model. And this is still a great way of showing atoms and their relativities. So we still use the Bohr model a lot. All right. And since I don't want to butcher names, we'll just put the first name and the last initial of the last name for these next two scientists. So Erwin S. and Werner H. And the time period we're looking at this is the 20th century. And there was many different scientists that contributed during this, and what their main focus on was the electron cloud. The electron cloud was the main focus, and what they found was that electrons do not travel on a specific path like Niels Bohr came up with. They do travel in certain regions much more frequently. And then the image in the textbook shows a darker region around the nucleus, which is the electron cloud. You can relate it to the Bohr model because the regions make up rings. So it does show that electrons kind of move in rings, which what Niels Bohr first came up with. All right, class. Now we're going to go on to the atomic structure part. The atomic structure part can be found on pages 318 through 325. There are two structures of an atom that we mainly focus on: the nucleus and the electron cloud. And those make up the two structures of the atom. All right? So like I said before, we have a Bohr model that kind of shows what we're looking at. So we got the nucleus here, and then there's three rings that surround it, which we say make up the electron cloud. Okay, so we got the nucleus up here, and then these three are the electron cloud. Like that. All right? And then atoms are made up of three subatomic particles. The proton, which has a mass of 1 AMU, which stands for atomic mass unit. It makes it easier so we don't have to memorize the exact weight of a proton. It has a positive charge, and its location is in the nucleus. So protons, you could draw a line, are located in the nucleus. And then neutrons are about the same as protons, 1 AMU, and they do not have a charge. They're neutral, kind of like the beginning of neutron, and positive for proton. That's a good way to remember it. And these are also found in the nucleus. So you could draw a line all the way to the nucleus. And then the electron, it's significantly smaller than the proton and neutron, so we say that it doesn't really have a mass, and its charge is negative. And the location of it is in the electron cloud. So there could be multiple electrons up in the electric cloud in those three layers. And there's a specific way that we draw those electrons in. Okay? And that's why we go into the atom building procedure. All right? The atom building procedure is really cool. So the atomic number is equal to the number of protons. And atomic number can be abbreviated with AN. All right? And like we said, the protons are up in the nucleus. All right? The atomic mass is the average weight of the isotopes of an element. Of an element. All right, class? And make sure we know the definition of proton and isotopes. Those are very important, as well as neutrons. All right, in the isotopes, vary in the number of neutrons. All right, so the way we get different isotopes is the variation in the number of neutrons. Okay, so we have the periodic table square right here. And then the number up here, say we have carbon, we'd put a 6. And that's the number of protons in carbon. All right? So the atomic number would be that 6 up there. And then you'd have the letter, which is C for carbon. And then you would have the number 12. Okay? So you'd have the number of protons and then the number of neutrons, which would also be 6 if it's not an isotope, so you'd get an atomic mass of 12. And usually there's a decimal point to this and a few other numbers, but we're just going to focus on rounding it to a basic number. All right? And going on to the electrons now, the number of electrons equals the number of protons. And that's very important because we want the atom to be stable. So there are 3 electron level energies. The inner level, which is the first level, has, you can have a maximum of 2 there. All right, 2 electrons in the first level. All right, and then the second level, which is the middle level, can hold up to 8. Now, when we get up to higher college education with science, they'll tell you that they're able to hold more electrons than 8, but for now, we'll just stick that the second middle level can only hold 8 electrons. And then the outer third level can hold 8 and above. All right, so those will be the focus that will focus on the first level, middle level, and the outer level. Okay? All right, so the first step to make it a correct Bohr model would be step 1, number of protons, and that equals the atomic number. All right? So say we're doing carbon still, we have 6 protons. So we can look up here to our periodic table, and that's the number of protons. And then step 2, we want to look at the number of electrons. So we know that the number of electrons equals the number of protons, so we'll have 6 electrons, like so. And then step 3, number of neutrons equals the atomic mass minus the atomic number. So the atomic mass should always be bigger than the atomic number. So the atomic mass equals 12, because it's the protons plus the neutrons, minus 6, which is the number of protons, and that gives us 6 neutrons, because we know that the atomic mass equals the atomic number plus the number of neutrons. All right, so if we were to draw a Bohr model down here, we draw one circle, which is the nucleus, and then we'd have the second cloud, or the inner cloud, and then the second one, because we know this one has 6 protons and 6 neutrons. We also know that it has 6 electrons, so we would have to put 2 in the inner shell, because we know that the inner shell can hold 2, and then we can put 4, the remainder, in the outer shell. And we kind of want them to be spaced as far apart as we can, because we know electrons do not like to be close to each other because they're like charges. All right, so that's the wrap up for the atomic theory and the atomic structure. If you have any questions, please just ask your teacher, and they'll be able to point you in the right direction. Thank you.